Hi everyone. We just want to do a quick introduction before we dive into the tutorial. My name is Stephanie Stattel. I work at Bloomberg. If you guys want to introduce.
I'm Jason Grout. I work at Bloomberg, and I've been working on JupyterLab since it was started.
And I'm Matthias. I work at University of California, Merced, and I've been part of the Jupyter team since 2011-ish, 2012.
Cool. So just a little bit of housekeeping ahead of when jumping into the exercises. So hopefully most people have already installed JupyterLab with the instructions in the README. So for the purposes of this tutorial, we're going to be following conda-based Python distribution. So if you have installation issues and you're using a different distribution, we might not be able to help you. But that being said, if you're having any installation issues, we handed out sticky notes. And so you see there's a red and a blue. So hold up the red if you're having trouble, and one of us can come and assist. So just a little bit of an overview of how this will work. I'm going to start with an introduction to go over the context and general design and motivation behind JupyterLab. And I'm going to do a quick tour of the user interface. And then I'll be handing it off to Matthias to do a walkthrough of some of the workflows. I'll be jumping back in to tell you and show you a little bit about how you can customize JupyterLab. And then we'll be wrapping up with some examples of extensions. And so if you have any questions throughout, again, please feel free to use the Post-its, and we'll be walking around to provide assistance. So just a quick poll before we jump in. How many people here have used the classic notebook before? Okay, awesome. Almost everyone. How many people have used JupyterLab before? Okay, so less. All right, this is good. You're in the right place. So yeah, like I said, I'm going to give a quick introduction to Jupyter and give some context in relation to the Jupyter Classic Notebook. So this is the current Jupyter team, which also consists of many more people. Jupyter itself started out as a collaboration between what was then Continuum, Jupyter, and Bloomberg, but it's since expanded to many, many people beyond that. So it's not strictly academic or business. So again, it's a very egalitarian open source community, and we'll be touching on that more as we talk about the design principles behind JupyterLab itself. So again, JupyterLab is a flexible evolution of the building blocks of Jupyter, which I'm going to touch on a little bit in more detail later. But at its core, Jupyter is a collection of extensions. And I want to emphasize that because we're going to revisit and expand on this concept throughout the tutorial today. So, a little bit about the Jupyter Notebook. It was designed to be interactive, exploratory, and reproducible. As a browser-based computing environment, it supports many different types of document formats, as you all know, since you're pretty active Jupyter users. It supports things like code, narrative text, equations, and interactive visualizations and outputs. It supports over 100 programming languages, and I want to emphasize here that everything is open sourced. So here's a screenshot of the Jupyter Notebook. And I mentioned before, this is built on the principle of the concept of interactive computing building blocks. And so these include things like a file browser, a terminal, and kernels, along with notebooks, text editors, and output. So for the last several years, the Jupyter team has been working on a new Jupyter frontend called JupyterLab. And so you might ask, why JupyterLab? The notebook itself was not easily extendable. It was built on an aging code base, and we were looking for a more organized infrastructure to extend and maintain. But not to worry, JupyterLab still supports the same file formats and kernels. So if you have notebooks that you were using in Classic Notebook, you're going to be able to run and edit those same notebooks in JupyterLab. So to reiterate, this is really a change to the front end of Jupyter, not the back end and notebooks themselves. So here's a screenshot of JupyterLab, and so you can kind of see here, and we're going to touch on this in more detail in the demos and later examples. JupyterLab itself goes beyond the classic notebook to provide a flexible and very extensible web application with a set of reusable components. So users can arrange things like their notebooks, text editors, their terminal output areas, and have customized components that use the tabs and things like collapsible sidebars. All of these components have been really carefully designed to enable users to use them together or separately. So, for example, you could do things like sending code from a file to a console with just a keystroke, or popping out output if you want to work just with the output alone. So a little bit more about the building blocks and how we've built on top of these. It's based on a flexible application plugin system that's provided by something called Phosphor.js. And this makes it really easy to customize one, existing components, or two, also extend with new components that you create yourself or pull from third parties. And so, as I mentioned, you can install third-party plugins, and Jason's going to touch on this a little bit more in the later examples, to do things like view custom file formats, such as GeoJSON, interact with external services, like Dask or Apache Spark, or display your data in different useful ways, with things like interactive maps, tables, and plots. So a few stats on JupyterLab today. It's over 5 years worth of development. It has over 250 contributors and about 70 components that are part of its core extensions. It has over 16,000 commits, and really exciting, 1.0 is ready for use. I think we've officially had 1.0.2 released today. Ish. Okay. 1.0.
1.0 is out.
Oh, 1.0 is out and more coming. So a little bit on that. Use it today. It's for general use. And I wanted to do a quick note too. The classic notebook itself is going to be eventually retired, just as a heads up. So again, we mentioned this before. In this tutorial, we're going to walk you through some of the best ways to make use of JupyterLab and how to transition from classic notebook front end to JupyterLab and make use of the features that you find within JupyterLab itself. And as I mentioned before, if you have any questions or concerns, if this is going too fast or too slow, let us know with the notepads, and we're going to be collecting feedback in the breaks as well. All right. So with that being said, does anyone have any questions before I jump into a quick demo of the interface? Sure.
Just a quick question about the notebook format and version controlling notebooks. Is it still going to be JSON?
Okay, the question is for the notebook formats and version controlling, will it still be JSON? Maybe Jason, I'll hand that question to you. I think it's the same, but yeah, I don't think that part of it has changed. Okay. All right, so what you're looking at here, actually, I might need to change the display.
I might add that JupyText is, for example, a plugin for the classic notebook and JupyterLab that saves notebooks in Markdown instead of in JSON.
Can you go to the microphone for the recording?
Oh, yes, sorry.
Is there another mic? You want me to go to the microphone? I'll just add that the format of the notebook files themselves is completely independent of JupyterLab versus the notebook. Those are JupyterLab and the notebook are purely front-end things. And there's a plugin, for example, for the classic notebook and for JupyterLab that saves notebook files as Markdown instead of JSON, so JupyText, and it's extendable so that anybody else can save notebook files and serialize them in whatever format they want.
Cool. All right, so I think what I've got launched here for you is JupyterLab. And so I mentioned before, classic Jupyter notebooks were built on this set of foundational building blocks. So I'm going to walk through what some of those building blocks look like within JupyterLab. I'm going to start with the launcher. This is what you see here. Sort of opens by default when you don't have anything else open. And this is something that you can use to open notebooks, terminals, consoles. So here, if I wanted to create a notebook, it's really quick to launch. And you can also see that there's a keyboard, a shortcut here to launch the launcher. And I'll talk a little bit more about keyboard shortcuts, but to start with, I'm just showing this as mouse click action. Yeah?
You mind maximizing it and then making the font size bigger?
Sure. Is there a maximize?
Yeah, just the green button. The green button up in the upper left.
Oh, the browser. Okay.
Yeah. And then can you Command plus to make the font size bigger?
Yeah.
Yeah.
Can people in the back see that all right? That size? Okay, great. All right, so I'm going to start by opening the notebook, and these are the familiar notebooks you all know and love. So here is a Jupyter notebook, and we're looking at code and output cells. And so some of the things that you can do within JupyterLab as far as your view, it's really easy to collapse. Let's say we want to collapse outputs. Let's see, view, collapse all output. I can also collapse the coding cells themselves. And it's also very easy, and this is sort of new here, to drag and drop cells. So if I wanted to move cells earlier or later in the notebook file itself, that's pretty easy to do. Okay, And so that's sort of the gist of the notebook. And again, we're going to be diving into more details of things you can do within actual notebooks later in the tutorial. And so I'm going to move from here to some of the left plugins that you see here in the browser. So I'm going to start with the file browser, and from here you can do file navigation. You can also perform basic file operations. So at the top here I can create new folders from within JupyterLab. And with the right-click menu, I can do basic file operations like delete, rename. This also supports drag and drop operations. So if I wanted to move my new notebook into a new folder, I can do that from there as well. Another one of the tabs that we have is the running tab. So from here, I can see which terminal and kernel sessions I have active. I can also shut down these sessions from this tab as well, which is pretty useful for a centralized place of management. One tab that I find especially useful, especially if you're not as familiar with all the different command options within JupyterLab, is what's called the command palette. And from here, I can search for different commands. So like I showed before, if you wanted to do collapse all, but you weren't sure where in the file menu that lived, I can search in the command palette for that. And you see collapse all code, collapse all outputs. If I wanted to do run all, also real easy to find and execute from the command palette. All right. I want to open to start, talk a little bit about the different file formats that you can view and edit in JupyterLab. So here we've got Markdown. So when I open, it opens by default in the editor. But I can also open this with the Markdown preview. Actually, I'm in a single view mode. So let's see, here I'm seeing the tabs. And one of the really great things about JupyterLab is I can really customize my output layout. So I can have the editing and the preview together shown side by side. And as I edit this, I can see the preview reflecting my edits in real time. So if I'm doing a second title, I can see that in real time, which is pretty handy. Something else really cool that you can do with Markdown cells here, if I right-click the tab, I can attach a console to this editor. And you can see here in this Markdown, I have code. If I wanted to run this code, all I have to do is select it and then do Shift-Enter, and this executes the code in the console, which is really great. And then if I wanted to produce output, I can do that as well by selecting the code and running Shift-Enter, and you can see here I have output, which if it was interactive, I could interact with it in the console as well. Hi, feel free to grab a seat. We were just getting started. Something that I kind of inadvertently showed to you early is what's called single document mode. So you can see here I have quite a few different outputs and tabs, but if I wanted to focus on a single file, it's pretty easy to toggle that. So if I'm going into single document mode, I can see just the Markdown editor, and it's pretty easy to toggle back out of that as well. All right, so I mentioned this is one type of file. We have a few other files that are supported. Some of these are supported by extensions, which I think if you've done the setup, you've installed a few of them, but some are supported by default. So let's say I wanted to look at CSV files. I can just open that and have it rendered in a table. Vega Lite is also supported, where we can view this as an output graphic, and also things a little bit more exotic. If we wanted to do, let's see, GeoJSON, this also supports rendering things by maps. And this is an extension that you'd install on top of the default core extensions. Great. Okay, so a couple of the new features that came with JupyterLab 1.0 I wanted to walk through and just show everyone. Really exciting is that we now have first-class support for find and replace in notebooks and text files. So if I go back to my notebook and let's say I wanted to, this is reached by doing Control F, I can find all the instances of pandas, and if I wanted to replace that with another imported library, I could do that. This is really handy for searching large files. Another thing you'll notice here is that we have a status bar at the bottom that's showing the status of my notebook, and right now it's idle. If I were to run all cells, we'd see this status really quickly change from busy back to idle again. Another really handy feature that used to be a separate extension is now installed by default as part of the core extensions in JupyterLab. Another thing that we have that we support, oh yeah, so if you do command find, if you're on a Mac, you'll want to have your focus in one of the notebooks or text files, and so that's definitely the initial set of support for command find, but that'll let you find occurrences of words and do simple replace on that. Yeah, sure. Cool. And so another new feature that we have in 1.0, for people who aren't as familiar with JupyterLab, these are probably just part of the package for you, but if you've been using beta versions of JupyterLab, these are really new and exciting features, is a printing system that allows extensions to customize how their documents are printed. Another new feature is that we now include Jupyter Hub as an extension as part of Jupyter Core extensions, where before you'd have to install that separately. And Jason's going to go into this in more detail later, but again, since everything here is extensions, it's really easy to customize and add your own set of either third-party or homegrown extensions to this initial set of features in the UI input. So yeah, I think at that point, we're ready to transition to the first exercise once Matthias is ready, but I'm happy to take any initial questions you have after this first demo. Nope. All right, thanks. We'll be back a little bit later for one of the later exercises. Thanks.
Thank you very much, Stephanie. So I'm going to go with exercise. And first, I want to make sure everybody knows about the sticky notes. The sticky notes are really helpful if you have issues. If you have issues, instead of keeping your hand raised like that and start to get like pain and everything, you just stick a red sticky note on your screen like that. And a helper will come and help you. So you should have received some instruction about cloning a GitHub repository or downloading it onto your computer. If that is done and everything is fine, you do the green sticky note, or the blue one. You stick it on your screen so we know that everybody is up to date. And this works at any time during the tutorial. If something is wrong, you will put the red sticky note, and if everything is fine, you put the blue sticky note. You try to remember to remove the sticky note, and that gives us an idea of how fast we can go. So here we are. And so hopefully you found this repository in the instructions. So otherwise it's github.com/JupyterLab, and then you find the SciPy 2019 JupyterLab tutorial. And from here, so here are some notes for me. And if you go into the README here, there is some instruction about installation. So hopefully you've cloned that and you have all the material on your machine. If you've cloned it last week, go back to this repository and do a git pull. You will get some updates. If you downloaded the zip, it's fine. You can re-download it. It's up to you. Then we went into the directory. Let me zoom a tiny bit. We update. And here we've created a JupyterLab Conda environment. We have some people that have issue with that. We believe it's due to the Wi-Fi here that is preventing Conda from connecting to the network, depending on your laptop. If that's the case, go on the Slack channel and try to connect to AT&T Conf with the passwords that they've given, which is given in one of the main Slack channel. We've created an environment to not change anything to your installation. So everything you will do during the tutorial will be done inside your environment. Go talk to the Conda folks that have done awesome things if you want to learn more about Conda. And so we are going to activate the environment first to make sure we are in this environment. And this line that you probably run after probably took some time. And here we are installing extension for JupyterLab itself. And some of these extensions are not Python, they are purely JavaScript. So we need to download them and recompile JupyterLab. So what you have is not a bare-bone JupyterLab, but already a JupyterLab with some extensions. And so once you're there, you should be able to have a prompt that looks something like that, depending on exactly how your computer behaves. And from this prompt, you should run Jupyter space lab, and hopefully you will have a JupyterLab that appear on your browser. And if that is not the case, you put the red sticky note. If that's the case, you keep the green sticky note. And in a couple of minutes, we will remove all the green sticky notes. And we're going to spend a couple of minutes to make sure everybody is up to date. So that's how it looks. It looks for me. You see that I've clone this repository in my dev folder. I'm going to do conda activate, I don't remember the name of the environment, glab tutorial. So now you see that at the beginning of my prompt, it tells me that I am in this environment. And now I will do JupyterLab. And if everything is fine, I have my browser that opens and show me JupyterLab. And here you can see some of the data you've already downloaded. You might not have all these kernels. That's because I mess around with Jupyter quite a lot. And you can see that I still have, I have Python 3 kernel, I have Bash kernel, and all of these are kernels you can install if you want. Go to this specific project and install those. We had a question earlier about file format between JupyterLab and Jupyter Notebook. Is there any change? No, JupyterLab is just a change of the interface. You can open the same notebook in JupyterLab and in Classic Notebook. For example, even if you have something which doesn't work in JupyterLab but still used to work in Jupyter Notebook, like some extensions, one of the nice features is go to Help and launch Classic Notebook. It's actually just opening a new URL, and you have access to this old Classic Notebook where you can go back to your habits. Like any other program, if you have the same file which is open in two applications at the same time, the last one to write wins. So be careful to, if you have JupyterLab and Classic Notebook, to not have the same notebook open in both. It's up to you. But you can create a notebook in JupyterLab, play with it, save it, close JupyterLab, open Classic Notebook, do some modification, close, and etc. That was great. Let me just to make sure I'm neither too fast nor too slow, and let you go to the break at the right time. Okay, so that's mostly how to start JupyterLab, and you will probably have seen that JupyterLab has a quite different UI from Jupyter Notebook, and one of the reasons was that we want to be able to do more, have windows side by side, and have extensions. We will go through all these UIs slowly, and we will rehearse things several times during this tutorial. One of the things I strongly encourage you to learn, especially if you want to be efficient, are keyboard shortcuts. We have a lot of keyboard shortcuts. We will see how to do them. If you see me doing something with keyboard shortcuts instead of the mouse and you're not sure how, feel free to interrupt me and say, hey, how did you do that? Because if you want to be really efficient, you want to not reach the mouse. You want to basically everything becomes natural for you. And so let me go back through the UI once again. I'm going to go full screen here. So we have the sidebar here, and you can actually change its size, which by default should show a file browser. What you see here by default with all the different notebook with different kind of kernel you can run, different console and other things here, is a launcher. The launcher will always open by default if nothing else is available. But sometimes you might want to open a launcher explicitly. So let me just create a notebook, a Python notebook. You see that the launcher disappeared. I have now something that looks like a normal notebook UI from the Classic Notebook. And if I want to create a new launcher, I will just go press this plus button here. I can, and you have several tabs here. So the first one, which is a file browser, plus will create a new launcher. And usually, if you want to create a new tab, you always almost want to go through the new launcher. If you add extensions that add new file types, it will come to the launcher, which makes it relatively easy to pick and choose what you want. If you want to create a new directory or a file, you can use this plus button, you can upload, and if you change things on disk in a different way, like for example, if it's the same server and you've SSH around and moved stuff, you can force refresh to reload the list of files. It should do it automatically, but you never know. On some of the icon on the side here, we have this one that shows everything which is currently running. You probably have seen it in Classic Notebook. Once you run a notebook, even if you close the tab, the kernel which is attached to the notebook and run things is still running. So you might want to make sure to shut down when it's, for example, using TensorFlow and TensorFlow is using your GPU. This small pane palette here is for the command palette, and so the command palette lists every actions, every commands, which is either in the menu or not in the menu that you can do at some point somewhere in JupyterLab. So if you don't know where somewhere is, or if you want to find what you can do, you come to the command palette and you can search. And there is fuzzy searching. So for example, if you want a new notebook, you can search new notebook and it tells you can create a new notebook. One of the nice features of the command palette is on the side here, you have the keyboard shortcuts that correspond to the current actions. And you can see that some actions are available only in some categories. So for example, you have file operation, you have help, and you can see, like, for example, right now I can't save, but if I wanted to save, it would be Command S on Mac or Control S on Windows. We will match your operating system and try to show the current symbol. When you want to do something, really look in the command palette and look at the shortcuts. Here we have some things with metadata. We have all the open tabs because you will see that there are things like single document mode, or sometimes you lose where your things are. So you can see every tab that are open here. And then some other stuff and extensions. This is probably not enabled for you. We also have the status bar at the bottom with some indication of what's happening, and of course the file menu at the top. And so when you install the JupyterLab extension, everything can be modified. None of that has a specific has a priority over others. There is no core things that we trust more than extensions. Everything can be replaced. If you want to completely disassemble JupyterLab and put back with different pieces, you can. If you want to change the side panel to be something else with your custom extension, you can. You just have to write it. So can everybody see JupyterLab? This UI, or do we still have issues? So it's good. Okay. So let me close the launcher, close the notebook, so the launcher comes back, and we are going to go back to our file view here. We are going to start with exercise 1 and see what we can do with JupyterLab. So in exercise 1, I have a notebook that should not be here, so I'm going to right-click and delete it. And you have exercise1.md and exercise1.notebook, which is a solution. I should have written solution, but if you're lazy and don't want to type everything, you can look at the solution. But exercise 1 gives you some of the stuff that you might want to do in JupyterLab and learn how to use the UI. So I'm going to double click on exercise 1, and it shows me my Markdown file with some instruction of things you want, I might want to do. And those are guidelines, especially if you've already used Classic Notebook. I invite you to stray away from this path and try to figure out if you can break JupyterLab, and then you can open a bug report. Or if you're still relatively new to Jupyter, try to do all of that. We have a question in the back.
Can you zoom in?
Oh yeah, can I zoom in? Yes, of course. So you should have this file, so you shouldn't need to read it here. You can probably read it on your own computer. It's in exercise 1 folder of the data you had to download for the tutorial. And the first thing it asks us to do is to right-click on exercise1.md and open it as a rundown Markdown called Markdown Preview. There are, I believe, about 3 or 4 ways to do it. Like I can right-click here and show Markdown Preview. I can right-click here and probably open with Markdown Preview. Can I click on the right tab and open Markdown Preview? Well, no, it's not there. So try to open a Markdown Preview. Open with Markdown Preview. So here you see that I have a new tab, this one with Markdown, which is rendered, which is slightly better if you want to read it, not if you want to edit it. So now I'm going to close the sidebar by clicking on it. I'm going to get rid of the launcher as well. And I have exercise1.md and exercise1.md, they have the same title because it's the same document, except the icon is slightly different. one of the things I can do, which we will see later, is I can get this tab and drag it around, and I can have both side by side. And do that again, I heard on the side here. We're going to go to that later. It's more like a tiling Windows manager if you're using Linux. You can grab the tabs usually, and you can move things around. We will play with that. You can play with it. Grab the tab. I'm still clicking and I'm moving my finger. And it says, well, where do you want to put this? And I want to put this on the side here. And when I let go, it will do 2 panels. That you can resize. And so if you want to try to play with it, try to remerge both into one, and try to resplit both. And here, because it is the same document in JupyterLab, actually I prefer this one to be on the other side, because that's how I do things. Those are views on the same content. Which means that if you change something in one of those 2 views, the other should update almost immediately. So for example, here right now, if I type here, oops, with typo, you saw that the preview on the side automatically updated. And that's one of the power of JupyterLab. It works in the same tab, probably not across tab, not with classic notebook. The file still hasn't changed on disk. Like if I look at the file on disk, this text is not there yet. But I just have 2 views on the same data. And that's something you will see often in JupyterLab. You have the same things with different views. And because it's within JupyterLab, you can have like multiple things. It's not really real-time editing. It's just different views on the same things. But anyway, that's just showing you that you can open the same document within JupyterLab several times. It's not a problem. It's only a problem if you open the same document within JupyterLab and, for example, a classic notebook, or within JupyterLab and Vim, or Emacs, depending on how many fingers you have. Okay. And so here I will let you go slowly through some of this Markdown file. I don't need to edit it, so I'm going to close here, and I will give you maybe 5 or 10 minutes to try to do some of this action, and then I will go through it myself to show you how this can be done. And feel free to ask questions. We can come around, try different things. If you find that something is weird or you don't know how to do it, ask the question, and we will go back to that. Can you remove the green sticky notes for now, and you can put them back in once you're bored and you want me to move forward faster? And if you have issues, red sticky notes.
Yes. Let me switch this to Markdown. What keystrokes do I need to access the shortcut key?
So we have a really good question here. The attendee created a new notebook and asked me, well, I want to change this cell to Markdown. How do I do that with my keyboard shortcut? Instead of giving you the answer, I'm going to show you how to find it. Give a man a fish and learn a man to fish when you know the thing. So the way I'm going to do that is I'm going to go on the side here and open the command palette. And you want to switch the cell to Markdown. So I'm going to try to search Markdown. And I have one of the entry here, which is change to Markdown cell type. And on the opposite side, you have the shortcut is M. So we're going to go into that into detail, but basically here in the notebook, I am in command mode. You can see that the side here is blue. We're going to go that into more detail later. And I can just press M. I should be able to just press M, and it's changed to Markdown. Now let me switch rapidly between code and Markdown so that you can see the difference. You can see that the prompt disappears and that there is a small drop down on the top that says Markdown now instead of code. And so if we go back slightly into how the notebook works, you have either edit mode, where when you type a letter, it's actually entered into the cell. Or if I press escape, you see that I'm not editing the cell anymore. I'm in command mode, and now every key I press is a shortcut. And so I know from heart by heart that Y switch to code and M switch to Markdown. And so you have to figure out how whether you are in edit mode or command mode. You can also look here at the bottom in this new toolbar, status bar, that you're in command mode. And if I click in the cell, I should be in edit mode. So everything I type will directly go inside.
This is great. Only suggestion is in the guide, it shows it in uppercase. So if you type it in uppercase, it doesn't work. It needs to be lowercase now.
So that's the question is in the command palette it shows uppercase. That's a convention on the OS you're in. If you go on top and click on well, I don't know, bookmark here, you see that bookmark this page is command D and D is uppercase. Okay. And I wouldn't do command shift D. I would do command D. But I understand your confusion. We try to stay on consistent with the OS. And we have a question in the back here.
I was to say, it may be helpful to remember that what you're pressing is the letter that's printed on the key.
Yes.
The letter printed on the key is an uppercase letter. That's why it's uppercase.
Yeah. So the other point is that on the keyboard, on the keys, the letters are printed uppercase. So what you see on the command palette here is actually the key that you would have to press. So for example, I don't know, I would have to try, I don't know. My key on my upper right corner is both plus and equal. Would the shortcut for plus be command shift equal to say that I have to press plus, or would it be command shift plus? But I think it would be command shift equal. And so command shift equal would be equivalent to plus. There are some weird things around international keyboards. We know about that. We're doing our best. I personally had a French laptop and some of the things I couldn't do. We are cornered because of the fact that we're in a browser. We can't use all the keyboard shortcuts. And so you will see that. The other thing that you might see that I'm going to show it to you now, because we are talking about keyboard shortcuts, is a delete cell 1, which is D, D. The comma is not press comma. It means release D and press D again. So you can do both Vim style, I'm going to call that Vim style keyboard shortcut, where you press a sequence of key and it does something, or you can do a Max style keyboard shortcut where you press many keys at once and it will do something. And so JupyterLab supports both. You can even do a combination where the first sequence is Command Shift Alt P and the second one is Control Alt R, and it will do something like that. And we will see how to do this on keyboard shortcut for you if you wish to. Let's resume the exercise and we'll come back to that. Okay, so that's a slow beginning because you're still digesting from lunch, I'm guessing. Except you on YouTube, probably you're not having lunch, probably eating chips while you're watching us. So exercise 1, create a new notebook, arrange notebook side by side. And so by that, I just wanted you to play with the tab layout to be able to both read the instruction and the notebook, to not have to switch between two different views. Change to Markdown and write some Markdown with bold, italic, and math. So we're already in Markdown here. We can change either with a drop down or with the M keyboard shortcut. And it was basically just to get you started. Here is a Markdown cell. You can put hash in front to put headers. You can put with underscore, you can do italics, and with star you can do bold, and I think it's 2 star. And if you want to have code block, you can do triple backticks function, pass. So it's basically just reminding you the default of what you can do with Markdown. We have some extension to Markdown where you can write math. So you can have inline math that are basically like inside the paragraph. Or if you put $2 you can have display math, which will take its own line and take a lot of space. You see here that's the square root. I don't really like it, so I can double click and I can add a squiggly bracket around here. Oops, so I now have an error somewhere. I need to put squiggly brackets here and here. Oh no, well, anyway, you can add squiggly bracket and it should be better somewhere. So the square root, I want it to go from here to here. And now the radical goes all the way across. And so some of the things you probably have done here, if you're used to the normal notebook, is double click or press enter to edit the cell. And if you want to render the cell, you will press Shift and Enter at the same time, and it will execute the cell or render the cell if it's a Markdown cell, and then select the next cell. If you're iterating through some code, what the next thing we're trying to make you do is to learn about Control Enter, Shift Enter, and Alt Enter. So from, I'm not going to print hello world, I'm going to do from NumPy, or just from random import randint, and I can do randint and shift enter, or 2 arguments, 1 and 100. When I do shift enter, it runs the cell and select next. But if you want to try something many times, you can do control enter, and it will execute the cell without changing location. And if you want to, if you're in the middle enough of a big notebook and you have if you're doing something like model.train because you're a machine learning person and you want to add a step in between here, you can do Alt Enter, and Alt Enter will execute and insert a cell just here. So those are relatively helpful keyboard shortcuts. So some of the Python specific features. So there are something that it's sometimes difficult to figure out what is a Jupyter feature versus what is an IPython feature specific to the kernel. You can ask yourself these questions. If I were to run the same thing in the terminal IPython, would it work? If it would work in the terminal IPython, then it's an IPython feature. It's not specific to Jupyter, so it would work only in some languages. So for example, we can do import pandas if we want to do some time series analysis, and then we can do pandas dot d, and if you want to know everything that starts with d, you can press the tab key, and the tab key will show you some of the possible completion. And here we have data frame offset, data frame index, and I press enter to select that, and now I can continue typing. And so unlike other IDE, here we are not doing type inference. We are also doing type inference, but we are actually going to inspect live objects, which means that if you have a result from a request, whether it's a 404 or 200 with request, the completion will be different because the IPython kernel knows which kind of object you have. The other thing that you can do with tab this time is with shift tab. So I'm going slightly out of order. If you press shift tab, you will get a quick help like that you might know from the normal notebook. This allows you to quickly see the signature of your object. And it works both from objects that are coming from libraries or from your own object if you've defined them, or functions if you've defined them before. The longer form of that is single question mark. That you can put either after or before an object and press shift enter, and it will try to pull as much information as it can from any object. So here the signature, the docstring, which file this comes from, so you know if it's like from your dev install or which library, the type of the thing, and if there are subclasses. This is relatively recent. If you want something, I don't know, if you have an artist in Matplotlib and you want to find all the kind of artists you have, you can do artist ? And it will find all the subclass of artists. Maybe not all, because otherwise it can be pages long. So at some point it says, well, too many, I'm just going to put ... You can also use 2 question marks, and this will be more aggressive. It will especially try to pull out the source code of this object. And so here I can see exactly how was data frame defined. So I can actually poke under the hood and see how things have been done. Okay. So Shift Tab, we talk about contextual help. If you're often asking for help, you might want to create a new launcher and create the contextual help, which is the last one. And this will try to get help as soon as your cursor is somewhere. So contextual help, I'm going to play around and put it here. And you see that as soon as I click on pandas, it pulls the pandas help, and as I click on data frame, it pulls the data frame help. So that might be useful, but it will work only when your kernel is not busy, and it can trigger some side effects. So it's not there by default. So after they ask you to use pandas, there is CSV to view data frame and plot it. I'm not going to do that. You can look at the solution in exercise 1, notebook.ipynb, where I go into all of that and show you what can be done. Of course, everything that you could do in previous notebook, like displaying rich object, works in lab, even JavaScript. So here I'm going to do hello SciPy, or I can also just do alert hello SciPy. So here I will publish JavaScript on the page that will trigger some things. Just as a side note, you should see, I don't remember what it is, displaying JavaScript on a page is a security concern, depending on what you're doing. So you might sometimes find that your notebook will appear as not trusted. A notebook is trusted only if you have run all the code in this notebook. And when a notebook is not trusted, it will not display things that might have security issues. And so you will need to explicitly trust a notebook or rerun all the code for this content to be displayed. Typically, think about Word and Excel macros. Do you want to execute this macro on this file? Yes or no? We have just the concept of trusted versus untrusted. If you've been the one who executed all notebook, then the macros will execute automatically at load. Does that make sense? Yes, no, maybe, I don't know. Okay.
Can you show them how to trust a notebook? Click on the status bar.
Click on the status bar here.
The X icon.
Oh yeah, here. The notebook is not trusted. True. It's there. I never remember. Before it was a text. So here the notebook is not trusted. There is a small shield with an X. No, I don't trust this notebook. And you should. It doesn't want to. I'm clicking on it.
Oh, go to the command palette then.
Command palette and trust notebook then. Trust notebook. Trust notebook. Trusted Jupyter notebook may execute hidden malicious code when you open it. Selecting trust will rerun this notebook in a trusted state. Okay.
Can you mark certain cells to only run when the notebook is trusted?
So can you mark certain cells are to be run? Well, you can't. Trust is something that you can only do on a complete notebook at once. I don't know who asked the question. Can you raise your hand? Oh, here, so that I can look at you. If you were to do it on a cell-by-cell basis, you could have the ability to forge notebooks that appear as trusted, but they're not. So basically, rm minus rf dot cd dot is not dangerous. cd dot 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 rm minus rf dot is dangerous. So if you trust each chunk independently, someone could take trusted chunk and forge something which is dangerous. If that makes sense. So no, you can either trust everything or nothing. And now it has restarted my notebook, re-rendered it, and now it's trusted with a small check mark. There is a database on your disk that says that your notebook are trusted. After really long time, they may start to appear not trusted anymore, and then you have to trust them manually. But that basically means that when you send a notebook to someone, they sometimes, for some output, have to rerun the code, but all to trust it. You can come and ask on the mailing list if you want more detail. This is a fairly small detail to just forget about most of the time. So what time is it? It's 2:30. Okay, so let me go back to where we are. Installation, breaking QA at 15. Oh yeah, creating view for outputs. So I'm going to just close exercise 1.md, but keep my notebook here, go back to full screen. So you've seen that you can do tabs with a single document, with multiple documents. And so here I'm just going to remove the pandas double question mark because it's taking a lot of space. Or I'm just going to go here and rerun all of that. There is a lot of, so here I wanted to do data frame, okay. So shift tab, I don't need that anymore. I can read iris.csv, import matplotlib and tell matplotlib, please put your plots in line. Look at head of my data frame and plot it, and it appears in line as you would expect in Jupyter. And sometimes, well, you start to have really long code that you don't want to look at. And so you can go on the side here and try to do some stuff like right-clicking, see what appears. You see things that split cells, clear output, enable scrolling for output, disable scrolling for output. And so what you can do is click actually on this bar here, and it will collapse or expand your output. So if you have something too big that you just want to hide, you can click here to completely collapse it. Or you can enable scrolling, and scrolling will just give you about 10 lines. So if you have really long output, you can enable scrolling. The other thing you can do is when you have an output like this one, and you say, well, this is something I will modify, but I want to keep it in one corner of my field of view and leave it here. What you can do is right-click and create new view for output. And what this will do is create a panel that you can drag around like anything else. But as we had our Markdown file which we're editing and our Markdown file that we are viewing, that were two views on the same data, here it's the same. It means that this output view is just a view on this cell outputs. So if I change this cell output, the output view will change as well. And so, for example, I actually want the color to be not C0 but C1. For those of you who have used Matplotlib and are used to put RGBK, you can actually use C0 to C9 and it will use the current theme color. And what you saw here is, well, actually I don't want only the sepal width and sepal length, I want the petal width, and it will, when I execute, it will update my view. And I can collapse that and have this here to keep an eye on when I'm moving around. So that's one of the things you can do. The other thing you should be able to do is to open a second view on this notebook. New view for notebook. Oops. I'm displaying JavaScript, so when I load this notebook, the JavaScript displays. So I'm going to remove that now. JavaScript, I don't remember what it was, so let's just comment that here. And so now that allows me, it's still the same notebook, those are still views exactly on the same file. So now if I want to work on two different cells, I can actually have view the top of my notebook here when I have my really complicated equations here, and these other things where I'm doing something completely independent, but I want to look at both because it's easier instead of having to scroll. I can now have things side by side. And you should be able to drag things between one notebook and the other, and that will just work. So you can take if you want to reorganize your notebook, instead of having to scroll up and down, you can get the top of your notebook with all your import on the right or on the left, depending on how you prefer things, and then go through your code and say, oh no, that I want at the top, that I want at the top, and you don't have to reorganize. Yep, that's what I just did here. We can redo it. We can take this, move a cell from one view, bottom, to other, top. And so here I'm at the top, here I'm at the bottom. I'm going to drag that cell here. And actually, it's duplicated it here. I can delete it here. And you could do it across two different notebooks. So let me create this other notebook here. I can bring that, I can take that and bring it here, and it duplicated that across my notebook. So now if you want to reuse something, you can move across notebook. So you can do that with, let's see, the collapse state of the cell should be independent, if I remember. Oh, no, this is this notebook. This is this one. No, they're not synchronized. So you see that it's the same notebook, because as soon as I collapsed or disable scrolling, it will affect both sides. And there are reasons for that, because it's the same underlying model. And so, of course, again, in this right-click menu, you have all the shortcuts. So how to cut a cell, copy cell, paste cell. You go into command mode and you press either X or V, double D to delete. If you have a long cell, you can split it in half, and you can undo some of that. And the contextual help we used before, that was here, you can actually open with just command I. So I, because it used to be called the inspector at some point, so I. Okay. Small favorite shortcut of mine, if you want to add cells in the middle of a notebook, you can create cells above with A, or below with B. So it's above and below, not before and after. So now you will remember. Or not. At least you will remember that it's A and B. Creating new view, book and console, file, collapsible cells. And so, yeah, one other thing that we will start to do in the next section. So you've seen the notebook, and one of the complaints we have about notebooks is that you can get out of order execution, but you're probably quite familiar with that already with normal notebook. And so what you will find in the launcher, let me reopen a launcher here, you will find consoles and terminal. So there is a big difference between both. Terminal is a full feature terminal where you can run all of your bash, ZSH, whatever shell you prefer, completely full feature. You can even run Vim from within that. What you want to, I don't know, but you can. So for example, if you're on a supercomputer and you don't want to SSH always, you can just reach for that. The difference with the console is that the console is more like the Qt console. And so let's create one with Python 3. It looks like a notebook, except you can't go out of order for execution. You can only write code at the bottom here, like do some fancy math, and you will get the result. But it's more in a linear way where you can't edit what has been done before. But as a notebook, it supports completely all the inline rendering. So you can do matplotlib inline with a space. You see that our contextual help is reacting immediately and say, here is what you can do with everything. Import matplotlib from matplotlib import pyplot as plt and plt dot plot range 10. Don't have any idea what to do, and you get your thing, but it's a linear way. One of the useful things about console that we will look at after, that they can be attached to documents. So when you have documents that are not notebooks that usually can't execute code, you can say, well, this document, Markdown or Python or whatever is supported by JupyterLab. When I press Shift-Enter, sends this code to the console and execute it. So if you want to do, for some of you, I've seen R over there. If you use R Markdown, you can, for example, put your cursor in an R block, code block, press Shift-Enter, and the code will be sent to the console for execution. So you can basically go through tutorials, if you're writing tutorials, and make sure that your code is working correctly. Okay. What time is the break already? Jason, do you remember? Nope. I don't want to get...
3, but I think we're ahead of schedule.
Yes, okay. Any questions so far? So is it a different workspace? By default, yes. And that's one of the things we will see later. You can actually attach to this, many documents to the same kernel. You can see that it's a different kernel because it started at 1 again. And so this means that it's different. But as you ask, well, let's go to that. Let's do kernel and let's do change kernel. And again, I'm going to go slower. Go to the command palette, search for kernel, and it says change kernel. For the console, it could also have said change kernel for the notebook operation. You see that here, because I was in the console, it puts the console result at first. And I can change kernel, and here what it asks me is whether I want to use, I want to start another kernel, or if I want to use a kernel from another session. And so it will refer to the kernel from other sessions as by the name of the other documents they're attached to. And so, for example, here I could go to exercise1.ipynb, select. So you see that it's just show again the banner. But if I do just one calculation, you see that it starts at number 22. 22nd, because the other notebook was at the state 22 at that time. And so now, yes, the kernel have a shared workspace. And I can look at, using IPython magics, I can look at who tell me all the variable I have in the current workspace. So who ls give more information? I don't remember. There is one that gives way more information. It's who's. Tell me that I have type object. Let me just put that on the side here. Actually, I'm going to try something else to show you, even if it's slightly in advance. You have single document mode. We'll try to remove all the clutter and show you only the current things you're working on. You see that there is not even tabs at the top, so that's how you can detect that you're in single document mode. And what you can see here is that I actually have a data frame here. I have my data frame from my other kernel. And so now you can have, if you want to do something really complex, you can have several views on several documents that share the same kernel. One other thing we don't have, and we can discuss about that after, is can one document have many kernels? No. Because what you want to do is have one kernel that dispatch to many languages. Does that answer your question? Okay. I want to exit single document mode. So Command Shift D, and I'm back to normal view with my contextual help. My notebook 1 that was at some point at 22 but out of order. And let's go back here and check that I am probably at 27 now. Yes, I'm at 27. So shared workspace. So let's get ahead of the break and actually go to attaching kernel to multiple documents. So I'm just going to clear all of that, get a fresh start. So I clear all my tabs. I'm going to go to my running sessions here tab, and it shows me that even if the documents are gone, they are still attached for some of them to a running process, a kernel. So I want to shut all of them down to just not use any resources. And I'm going to go back, go to exercise 2, exercise 2.md, and open with, actually just open. And show Markdown preview as we did before, and read off somewhat of what is here. And so it shows you that's basically what you ask, and we're going to do it before the break instead of after, to operate report.md and follow instruction and experiment along as you wish. Again, if something is not intuitive or not in the place you expect, you can write it down and let us know. And so let's open report.md with our editor. Put it on the side here. Let's remove that for now. And right-click somewhere on this document and create console for editor, which I was telling you about a few minutes ago. There are other ways to do it, but now I'm going to start one with the Python 3 kernel and put it on the side here. And so I'm here just learning about the iris dataset again. I'm using pandas. And what I can do is if I put my cursor into one of the fence block and press Shift Enter, it sends the result to the console. You might have seen for a fraction of a second the one was a star, meaning I'm actually currently doing computation. And now it's done. And so now I can actually say, well, now I want you to read my CSV. Now you can switch to the console and say, well, what are the things available in my data frame? And it hasn't changed my Markdown document. And I can, the same thing, I can say, well, now I want you to execute matplotlib inline and plot scatter. So I will let you play with that. And the next section, which is about categorical, you'll see that we are going to use a library to transform one of our columns. It's just an ugly library, a few lines, into categorical, but the library has a bug. And one of the things which is often annoying if you have a bug in a library, because you can't reload module in Python, is that you may have heard often that you restart your kernel and run all, so that it takes into account all the changes you've done to your Python file. With IPython, there is an extension called auto-reload that will try to monkey patch for you everything that has changed on disk. So if you do a change to your module because you're extracting something from within a notebook to a library you want to share on PyPI, you can just edit it, and next time you run an next cell, it will try to figure out all the function and all the objects that have changed and update them. And that's what this exercise is about, is try to fix the library and see how you were able to use the updated file without having to restart and run all. And we can take about 10 minutes and then go through the solution. And again, if you have issues, red sticky note. If you want to go faster, you put the green one, and we will speed up. If you want to do some more fancy stuff, you should be able in every text editor of Jupyter to put several cursors and type at several places at once. It might be useful to replace variable.
I don't think
can get help on import, because import is a native Python thing. So let's try. Let's do new Python 3 notebook.
Oh yeah.
Oh, sorry. Missed that.
225 to 4.
So 225 to 4. Yeah, okay. So the question was, can you get help on import? No, because import is a Python keyword, so it doesn't have any help attached to it. And the global question was actually, how does the contextual help works? Is when you have a defined object in your Python namespace, as soon as your cursor is on this object, the contextual help will try to pull information about this object. So if I just do PD, it will get information about pandas. If I do import numpy as np as well, port import numpy as np. If I do np, it gets help for numpy. If I do pd dot data frame, as soon as I am data frame, it will pull help about data frame. But you have to get your object imported and in your namespace, because we're going to actually inspect the context. Like if I define a function and say, this is my awesome function, which is a useless documentation, as soon as I type fun, it pulls the information about function with a doc string, which is this is my my awesome function.
Okay, excellent. Thank you.
It's basically doing the same thing as question mark, but automatically for you. Because there is one thing in the Jupyter protocol which is, hey, can I get information about this thing? Does that make sense? And the food is here, so if you want to get a break and get some food, it's here until 4, so you have slightly about 1 hour to get food. You might also be interested in creating a new terminal and also tried some of this feature into terminal IPython. I have my issue, and so if you are in the terminal and do IPython, most of the things we've seen so far with auto reload will work. For example, will work here. So you can do import pandas as PD, and PD question mark, and you will get help on pandas. So one small question we had, which is slightly unrelated to Jupyter itself, is how do I update, if I had an old version of JupyterLab to a newer version? And one thing that was in the instructions that you might not have seen is this small -c condaforge. So is everybody aware of what condaforge is? Who is not aware of what condaforge is? Like everybody knows what condaforge is. No, you don't. Okay, so some people don't know what condaforge is. You know about conda, you use conda. So conda is a package manager, which can pull package from different sources. And by default, when you install conda, it installs things from the default channel, which is managed by Anaconda INC, X Continuum INC. And so, because it's managed by them, it tends to be more stable, more thoroughly tested, and has support. But there is also channels, so the way conda is channels, that are managed by the community. And one of them is condaforge. So if you Google for condaforge, you will find this website. Oh, it's not 2R, but that tells you what condaforge is. But the website is not the most interesting thing. It tells you like basically how to configure your computer to use condaforge by default, so you don't have to do -c condaforge. The interesting part of condaforge is the condaforge organization on GitHub. Condaforge. So Wi-Fi is slow. And the way it works is you, as a package maintainer, can publish something on CondaForge. So for example, I have access to IPython feedstock. And what that means is when last week I released IPython 7.6.1 because there was a bug on PyPI, a bot automatically say, hey, there is a new version of IPython. Do you want to also publish it on CondaForge? And I said, yes, it's fine. I just have to merge. The bot has almost nothing to do, but sometimes you have manual things to update. And now it means that IPython 7.6.1 is automatically published on CondaForge. So if you're on CondaForge, you will have access to more packages that will be more bleeding edge, but you have more risk of having the package to be broken because they haven't been tested thoroughly enough. It's rarely the case because they're tested like before they're published, we run a test suite. And so basically, if you're looking for packages that are not on normal Conda, you want to configure your Conda to also use CondaForge, and then you will be able to pull things from CondaForge. And you're in a company and you have some internal tools that you want to deploy using Conda. You can also deploy your own channel and build with different options or with a different compiler and get all the benefits of Conda with the isolation of having of controlling your own channel. And so you will find that CondaForge is one of the most successful. You have other smaller ones, like on top of CondaForge, you will find things at BioConda. So if any of you is in is biological science, you can look for BioConda. And instead of doing -c CondaForge, you will be able to do -c BioConda. And now you will get packages that are more targeted for bioscience. And they're not limited to Python packages. You will have also the -cr, where you can install things from the R programming language. You have JavaScript also, and you have things like that. And so those are just different channels that are controlled by different people. The CondaForge one is maintained by the community, where each package author is also a maintainer of the package on CondaForge. And so if you want to update your JupyterLab and you're still on 0.35 something, you want to not forget to put this -c CondaForge, and it should be able to find new version of JupyterLab. And here we have the BioConda page. Hope that make some of that clear. There are going to be a CondaForge buff if you're interested in CondaForge. I don't remember where, but if you look at SciPy 2019 schedule, so buffs are birds of a feather for those of you who are new to SciPy. So it's basically more or less informal gathering about a specific topic, which can be either more two-way discussions and one-way discussion like these tutorials or the talks. And you can look for CondaForge. Buff CondaForge, which is 1 p.m. to 1:55 p.m. on the 12th, which is Friday. Yeah, probably. So that was it for the apartheid, and for you on YouTube if it's recorded. And let's go back to our JupyterLab. We've also turn off the lights, thank you, so that it's probably easier to see. But some of you have already found that we can also switch JupyterLab to dark theme. We'll see that later. Because you know that if you want to be a real hacker, you have to code with a dark theme at night with a hoodie. It's true, yeah. We have real hackers here. Okay, so let's get back here. Remove that. And we were trying to play with attaching multiple notebooks, multiple consoles to multiple kernels, and playing with auto reload. So let's get back to where we were here. So let's load auto reload 1. So there's also auto reload 2. One means that you have to be explicit about what you want to auto reload, and the other is auto reload everything except what I tell you not to auto reload. You can look at the documentation by doing % auto reload and then question mark and read that. Not too important for now. remove the contextual help, and let me run this code that fails with a big traceback. You have to not be scared about traceback. Tracebacks are nice, they are friendly, they are red and scream at you, but they like you, they give you a lot of good information. If you're scared about traceback, another nice things in IPython that you might want to look at later is Xmode. Xmode can change the verbosity of tracebacks to way less if you are just want to know that there is an error but not more, or way more verbose, so it will try to inspect each frame and give you the value of each variable. So you don't have to use your debugger. It can tell you X was actually 12 when you were here. Look at that later. But basically here, well, our library file that we developed, which is extremely complicated, which was in exercise 2 and lib.py, has a bug. Well, actually, instead of this line, we actually want those 2 lines. Yeah, I mean, it was tough. You figured that out on your own. So how do I, like, if I want to redo my analysis here, it's fast. It takes a couple of seconds, but it can be something way bigger where it takes a minute or 2 to load the dataset. You don't want to restart your kernel and run all, but hopefully we have auto reload. And so we can comment the wrong line and uncomment the right line, save our file. And now if we rerun the same piece of code, our code has been updated. So auto-reload and IPython figured out that lib.py was changed, and it found the category 5 function and updated the category 5 function, so now we can use our category 5. And you can see here that it's the same thing as what we did before. We plot on our iris dataset, we plot the sepal length versus the sepal width. I don't know why it doesn't show. And the color of the dot is actually which species we are. This is not really important, it's just to show you that you can use auto-reload to be efficient when you're developing a library. Excuse me. You can, of course, use that in a notebook if you wish. And auto-reload does not only work with functions, but with objects. And if you reload objects, it will try to attach new method, detach method you have removed. It can't do all the things. Sometimes you have to restart, but it's quite useful if you want to work on a library. So let's try to also see if we can close all of that. Go back to our things and have notebook A and B and see if we can figure out how to attach notebook A and B both to the same kernel. So we have A equals 3 here, and we want to know the value of A here. And we see that, well, not the same workspace or not the same kernel as we said in Jupyter. And so how can we change that? So one thing you can do is to actually go here or search in the command palette for change kernel. So you could have run that. There is no shortcut, but you could make one if you wish to. We're going to go here and say I want to change my notebook to actually be the same kernel as notebook A. Okay, select. And so now hopefully the kernel has changed and A is 3. And if I change A to 5 here, and I ask for A here, it's going to be 5. You can do it. It's not because you can that you should. It can be extremely useful if you want to prototype something. But, you know, it can be quite confusing to figure out what was happening and what was done where when you do that. It's just possible. And if you wish, you should be able to also open new console from notebook. And same thing, your console will be attached to the same kernel. So I can ask A, and A is 5. And I should be able to create a new document here. If I get my new document. And if this document, I'm just going to put some code here, and ask for the value of A. You can't attach a document directly for a kernel, but what you can do is you can create console for an editor. And the console you started, you can also attach it to the same notebook, to notebook A. And so now I'm going to put that here. I have a console attached to exercise 2. Yeah, it's mind-bending. And I can execute A on this text, in this text file, that sends the code to this console, that executes that in the same kernel as those two notebooks, and now you basically have several documents that share the same namespace. So it's a really powerful tool, but double-edged sword, which you need to be able to manipulate at some point. So let's close all of that, and now we can go back to also all our kernel session, and we see that we actually have only 3 kernel running. Well, no more now, and you might want to shut down your kernel to be sure to free all your resources. Okay, let's see what else was in exercise 2. So we saw all the running kernels, stop unnecessary kernels, and free compute resources. So we saw how to attach a notebook to a console. You can have a notebook and attach and send and share data, use as a scratchpad. You can attach a Markdown file. You could do it with a py file as well. Like if you don't want to use auto reload, you can just select a new function you've updated and do Shift Enter, and it will be sent to the kernel and execute in the kernel and overwrite the function you have. If you want to, you can try to see what happened if you have a notebook here, a equals 3. Let's clear all output actually. Clear output. So let's do a equals 0. Start a kernel, do a equals 3. Let's save it. Let's close that. The kernel is still running. What you can do is go to help and launch classic notebook, just to show you that classic notebook sees the same notebook with the same running kernel. So it just view, you see that it's still running, and if I do exercise 2 here and ask for the value of a, it's still a equals 3. I can say a equal hello SciPy, it's late. Jet lag is hard. Save it. I'm going to go back here. Yes, it's hard. Jet lag is hard. I can go back to JupyterLab. I can reopen my notebook A, and you see that it's still the same document. So the question for compatibility we had before, they are exactly like talking to the exact same web server if you understand how Jupyter is working in the back. We are just changing the fancy UI in front of it. Question?
Is there a way to view notebooks without starting the kernel?
Is there a way to view notebook without starting a kernel? I think you can switch to no kernel, but I don't think there is a way to start directly with no kernel. We are going to have sprint on Saturday and Sunday if you are around. So you can come, and that's one of the questions, like do you start a kernel or not? One of the things that we also don't want to perturb users too much. And one of the things that the classic notebook was doing is automatically start kernel when you start a new notebook. Because what we don't want you to happen is for you to view a notebook and want to run some code, and when you decide to run some code, then it asks you which kernel you want. And because kernel can take quite some time to start, well, maybe not on my machine, but on some people's machine that can be like all laptops, we pre-start them. But that would be a nice thing to be able to say. Start a kernel, do not start a kernel, and have a view only things. We did open the notebook with same kernel, and we shut down all the kernel. So we can try different layouts. We've seen that when you have many layouts, it can be difficult to figure out what's what. Oh yeah, and one of the things we haven't seen is that JupyterLab is auto-saving the layout. So if you refresh your page, or if you close the laptop and reopen, most of the things will stay. Not everything, but JupyterLab is relatively resilient. Something happened, some noise. relatively resilient to refresh. One thing that you will hear about, that we won't go into too much detail here, are workspaces. What happens if you try to open two JupyterLab to the same URL? You will see something that pops for a few seconds. You see clone auto T here, and basically it's made two different workspaces that are independent. And so now, if I change the layout here and I save, the layout between this URL and this URL will be two different layouts that are kept depending on which URL I go to. So if I copy this URL, close this tab, reopen the tab to the same URL, I should have side by side, hopefully, if everything is fine. Yes, I do. And if I copy this link, close the tab, and open a new tab with this URL, I should have the two overlaid things. So if you have different projects where you want to have different layout on your big 50-inch monitor, you can do that and have a JupyterLab for data analysis and a JupyterLab for focus coding.
You can rename this by changing
the name. I just change the name?
Yeah, you can just change the name.
Here? Stuff JSON
Workspaces
says. Oh.
You deleted the slash.
Workspace. Stuff JSON says is always true.
Did it get rid of it?
It got rid of it.
How do you add, change the name of your auto workspace? How do you give a name to the workspace?
Go to command, search for works.
You must use clone. There's no auto copy then.
Well, anyway, Jason will show you that later. He knows these things better than I do. Or Darian.
Darian wrote it.
Darian wrote it. Okay, so you have to ask him. You have to open a bug report for Darian and say, "Hey, it doesn't make sense." No, and true. If something is wrong, it's our fault. If something is right, it's because of Darian. That's how it works always. Okay, and we did single document mode before that you might remember. Command-Shift-D, just put one thing full screen. So that's you can focus, and it is now 3:30, and it's going to be time soon to go to customizing JupyterLab. So it will be you again. And thank you. If you have any questions or if you want to go faster, green sticky note if you want to go slower, red sticky note.
And whoever was having problems installing JupyterLab on Windows, we've got two Conforge experts here working on it. It's a great thing about being SciPy.
Cool. All right, so exercise 3 is all about customizing JupyterLab. So for this, I'm actually going to walk through a few of the ways that you can customize in general. And the exercise itself is going to focus on keyboard shortcuts, which I'm going to go over quickly just to give you more time to explore on your own. And then we'll regroup after about 10 minutes of independent work to go over some of the tips and tricks around setting up keyboard shortcuts for yourself. So there are a lot of quick ways to change settings. So Matthias mentioned before that theme is one of them. So as far as if you want to be a true hacker and go in dark, that's really easy to toggle. So we'll leave that. Maybe I'll change it back to light for now and switch back in another way. There's also a lot of customizations you can make to the editor. So you can see here I have just a Markdown file opened in the text editor. And if I wanted that to also have a different theme, I can set that here. So I'm going to settings, and then I can see text editor theme. If I want that to also be a dark theme, that's really easy to change as well. I can also set the key binding. So if you're like me and prefer Vim, that's something you can do now with the key maps. You can also increase the font size. So here, and I'll actually take some time to increase this too. Can everyone see that from the back? Size-wise? Nope. Bigger? A little bit better? Cool. All right. And yeah, before we jump into key bindings, I want to open what we call the advanced setting editor just to talk a little bit about our JSON configuration logic for changing things. So you can see here, I got to this by going to settings and then the very last option, advanced settings editor. And so on the left-hand side, you're going to see a series of things that I can configure from, something as basic as the theme to things like, file browser settings, text editor settings. And something to note here is that what you see on the left as system defaults is pretty much read-only. And what you override is set in the right-hand user preferences. So here I can see that the system default is JupyterLab Lite. If I wanted that to be dark, I would go over to my user preferences and set it to dark. And you can see here, once I save this, it goes into effect immediately. So I didn't have to relaunch Jupyter to see the dark theme go into effect. And that's true of any settings preference that you're going to set from the advanced setting editor. So I'm going to go back to light. All right. And like I said, the majority of this exercise is going to focus on keyboard shortcuts. And so for this, you can see this lists out a lot of the commands. And so when we were looking at the command palette, Matthias mentioned before, some commands do have keyboard shortcuts and some don't. So there are sort of three flavors of ways to customize your keyboard shortcuts. You can take an existing keyboard shortcut. So let's look at something like toggle view, toggle mode. So let's say this is our setting for toggling between single and multi-view. We've touched on that a few times this tutorial already. So you can see here the key binding for this is something a little bit more complicated. And let's say I just wanted to disable that altogether. What I would do is copy this setting from the system's default and put it into user preferences. So you can see here, I don't have any custom keyboard shortcuts yet, but if I put this in here, and this is actually pretty nicely commented in the list of keyboard shortcuts, if you want to disable it, you'll see there's this disabled true property. So I can actually copy it over here and then add disabled true. And so basically what this does is overrides the system default and takes away any keyboard shortcut for this command. Similarly, if I wanted to add my own keyboard shortcut on top of an existing shortcut, I would just add that to this list. I could take out disabled true, and if I wanted to have, in addition to Excel's Shift D, I could have just Shift D as a way to toggle the mode. Let's call, maybe for simplicity, like Shift T. And so to this I've saved, and so now I didn't have to restart for this. I open this, Shift T, you can see now, I guess you can't see me clicking, I am clicking Shift T, you have to believe me. And you can see I'm toggling. Something also to note that's a little bit of a nuance in the settings for these, you can see that this is an array. So here I just have Shift T. If instead I wanted a sequence of keystrokes to be my shortcut, let's say I had T and I wanted to be able to hit T twice and have that be, let's save this. One hazard of having Shift and a character as your keyboard shortcut is it will keep you from being able to do capital letters in your cells, so try to avoid that one. Okay, and so here I've had T, and this is in the array, so when I have a document open, hitting T twice, let's see, with the right focus, will toggle between the single view and the multi-view mode. Let's save that again. All right, there we go. You'll have to trust that I'm hitting T twice here to get that shortcut. All right, so a little bit on exercise 3. This kind of walks through a couple of ways. And so I mentioned there are ways to override, disable, and add to existing shortcuts. So here it gives you some prompts for doing that. And at the end, I'm going to walk through some trickier concepts like plus and minus. But yeah, feel free to get started. And if you run into any issues, definitely use the Post-it notes and we'll come by and help. Great. I guess one more thing to mention while you're exploring is that you'll notice the third option here in any of the keyboard shortcut commands is the selector, and that generally tells you where the focus needs to be for the command to take place. And I'll admit, even for myself, this isn't the most intuitive, but in general, most of the things that you'll want to have shortcuts for do have a default option. So I generally work around that just by copying this and then leveraging what's already selected as the source. Another way to do this is to actually look through the source code of JupyterLab. But in general, this will be a pretty comprehensive list of things that could have shortcuts. I think also in the exercise, things like run all, you'll find that it doesn't have a keyboard shortcut, but it's still listed here with, like, in this case, like toggle right area doesn't have a shortcut. It's listed without any keys, so you can just copy that. And it already has a selector as body set for you, so you don't have to know that by heart. Yeah. Any questions on keyboard shortcuts or customizations? Nope. Cool. Oh, you mean for specifically keyboard shortcuts or just in general?
Has at least 155 lines.
Oh, for me, yeah, because I had just copied this over. So usually by default, user preferences, let me open one I haven't modified too much. It will show as just like an empty object. And these will persist the next time you run JupyterLab in this directory. It will know what you've previously set as preferences, so you won't have to keep adding the same keyboard shortcuts or overrides that you did from previous sessions. Oh, yeah.
Override, you just have to write on this.
The question was if to override, you just add it to the right. And also something really nice about the editor here. So I'll go back to my keyboard shortcuts. We'll delete these just to make it a little bit cleaner to read. If for some reason I introduced a syntax error, like foobar, it's going to show me at the bottom that I've had invalid syntax and it won't let me save. So the nice thing is here is you have some guardrails where it won't let you save any invalid settings that would give you issues when running. And so now that I fixed the syntax, I can save again. And it also tells me that there were no errors found. I will say, though, as far as validating, it's a good idea to look at how they're referencing the different keys. Like, control is a good one. So if you put an N in there, it might not catch that you've spelled the key wrong. So if you're wondering why something's not actually the right shortcut, use the left-hand side as a reference for how it's defining each key on the keyboard. Sure. So basically, if you want to disable something, it's kind of a two-step process. You're going to copy what's currently in the system defaults. So if I want to disable something like activate next tab, I'd copy all of this into my user preferences. And then I would add this disabled true property here at the bottom. And then you'll want to make sure to save for it to go into effect. And also another thing to note is if you don't necessarily want to disable an existing keyboard shortcut but add an additional of your choosing, you don't have to do this disabled step. You can just add, this entry with a different set of keys for your shortcut. And so then you'll have two keyboard shortcuts in addition to the default. Oh, so this goes back to before the question around why things were shown as uppercase. In this case, it's just what shows up on your keyboard, so there's no real sense of like capital B. So if I do Shift B, it's just Shift B, or like Control B. It's not necessarily that it's capitalized, it's just that's the keystroke that you'll be making. That's why I'd say too to be careful if you do a lot of shift character shortcuts. It won't know the difference between that being a shortcut and then you maybe in a notebook file or markdown file trying to put in a capital letter. So I'd recommend avoiding that and having, shortcuts that maybe won't overwrite things you might be actually trying to enter into cells. Also something, too, is some keyboard shortcuts are reserved for Chrome, so you'll find that Chrome will still focus if you try to set something like, the Mac Command T will make a new tab instead of whatever you're trying to override it to. So that's just something to be mindful of too. Sometimes it's a little bit of trial and error. Yeah. Oh yeah, go for it.
Sorry.
Oh no.
So this screen that you're looking at, the setting editor, it is the sort of lowest common denominator for all settings. And as you can plainly see, it's kind of difficult to deal with keyboard shortcuts in this UI. There is a currently not up-to-date extension for giving you an actual GUI to change your keyboard shortcuts. And we are going to get that up to speed soon, so you could install that separately. And in a future release of JupyterLab, hopefully 1.1, possibly 2.0, that'll be one of the packages that ships with JupyterLab. This will always work, right? Because this will be the underlying data source for your keyboard shortcuts, and all this information that you see here, this format will remain, but hopefully you won't have to use this for very long. So.
Come to sprints.
So it's possible to define another theme, I suppose, before it was very adventurous.
To define
Another theme, like
Oh yes, you actually can. So actually Jason might cover this in the extension section. I guess, could you say themes are their own flavor of extension at this point? So you can make your own theme extension. I'd guess too, if you did some Google searching, there are some themes out there.
Can you refresh the page?
Yeah, sure.
So you have, when you just refresh the page, you see that you have a nice spinning Jupyter logo here. On my home machine, I have a link there. So you can, it's an extension. Everything is an extension. You can replace anything. It might just be a lot of time.
Yeah. Another type of extension that might get covered, sort of related to theme. If you'd like extensions that handle certain file types and render them in a certain way, that's another option that you have to in the same way that I can control from the settings, like how my text editor appears. If you want to display or render certain data type files or images output in a certain way, that's one thing that the extension universe provides you. Yeah, so has everyone made good progress on the keyboard shortcuts? I think give it another couple minutes and then maybe we're ready to, this kind of segues nicely into the extensions work. Great. I think I'll leave it at that. No one has any questions? Thanks. Hand it over to Jason. I guess do we want to take a quick break?
Let's take the food goes away in 15 minutes. So let's take a
Sounds good.
10-minute break and get one last thing of food and then be back here at 5 to 4.
For those in the back, food goes away in 10 minutes and come back at 5 to 4.
So we're running ahead of schedule, and so I think I'll give you first some tips and tricks, some of my favorite features of JupyterLab, and then we'll go into writing a simple extension together. So one thing I want to point out is that there's quite a sophisticated windowing split layout system that we have here. So you probably have already discovered if you take a tab and you drag it over to the side, it can split the current panel. If you drag it to the bottom, it splits it so that the two panels are vertically on top of each other. To the right and up, splits each of the ways that the blue area indicates. If you drag to the center, here let's make two panels so that makes more sense. And I'll use Command B, or we could use the View menu Show Left Sidebar to hide the sidebar to the side. If I drag it to the center, then it's going to take the tab from the left panel and put it on the right panel. So to put a tab into a panel, you can drag it to the center of that panel, or you can drag it to the tab bar. Either one will take the tab and put it in that panel. So here I put the tab over in the right panel, And to drag it back to the left panel, I could either drag to the tab bar, or I could drag it to the center. The center is a bit bigger target. That's typically where I drag it because it's easier to hit it. But it's maybe not the most typical target versus dragging to the tab bar. There is something that's a little more sophisticated here, though. What if I wanted to, if I have the split layout, have one that went all the way across the top? And so one of the things you can do is right here, it would split just the left panel. Right here, it would just drag into the left panel. But if I keep dragging it up, now what it's going to do is it's going to split across the top all the way across. And so I end up with a layout like that. And so it's very easy, even if you have a bunch of split panels, to drag something to the very, very corner and get a split panel all along that edge. And similarly, if I have a split like this, so here on the right side I have a split so that I have two panels stacked vertically. What if I want to get another panel that is actually all along the right hand side? Again, if I drag it to the right hand side of each one of these panels, I'll just split that panel like that. But if I want to have a split all the way across the right hand side, I just drag it all the way over to the edge. And then I end up with a split all the way across the side. So if you have a pretty complicated split layout, you can still get one split all the way across by dragging it to the very, very edge. All right, so that's one thing. Let me consolidate all of these again. All right, another thing, look at right-click menus. We spent a lot of time thinking about how right-click menus work. And so right-click menus often give you a lot of operations that you might like. So for example, in a notebook, you have enable scrolling. This is something that a lot of people have questions about. And I'll illustrate it. So here I have a rather long output. It might be a table or whatever. In the classic notebook, you could click over here on the left-hand side, and it would shorten it and just let it be scrolled. And in JupyterLab, we do that by right-clicking and enable scrolling for outputs. And it saves that setting in that cell. So from now on, this cell, whenever it's run, will be scrolled like this. And you can even see that in the cell tools, this little wrench icon right here. And if you go to the advanced tools, you'll see in the cell metadata that it says that it's going to be scrolled. So you close the notebook, you open it back up again, and it'll still be scrolled when you run new commands. In order to unscroll it, you disable scrolling for outputs. And this works for any ones that are selected. Here it's just a single output that's selected. So that's another feature. Right-clicking on a tab gives you some nice commands, like close all the tabs to the right, rename the file, etc., show a new view for the file, etc. So look at right-click menus, and also look at the menus up here. We spent a ton of time trying to figure out exactly what to put in these menus up here. Like the view menu, you can hide and toggle the left sidebar, etc. So try looking in the menus to find commands, especially if they're common commands. All right, another thing to show you. So one of the things about JupyterLab is we have a bunch of tools that are together here in a single environment. We try to make the tools work really nicely together. Stephanie showed you some examples of this. I'll show you a few more. So if you have two notebooks that are side by side, you can actually drag cells from one notebook into the other. Or if you even have the same notebook side by side, so here I'm going to open up a new view of the same notebook. Let's pull the sidecar notebook back here. So now I have the same notebook opened up twice, and maybe it's a long notebook and I have some cells down at the bottom and cells at the top, and it's easy for me to drag cells from one view of the notebook to the other view, and it just copies the cells from the bottom of the notebook to the top of the notebook here. We can also, as Stephanie showed, attach consoles to various files. So I'm going to attach a console, new console for this notebook. And so here's a kernel console that's attached to the same kernel as the notebook is. And if I just want to test some things out, etc., I can just drag a cell straight from the notebook, drag the cell from the notebook down to the console, and it pastes the code down there. And it could be a long cell, it could be a short cell like this, and it lets me start to play with this thing. In fact, it gets even better than this. There's a command. If we go to the settings menu, you'll see that there's a command to automatically. Sorry, my tabs are getting a little big here. All right, so I've enabled one keyboard shortcut for this command notebook run in console. And so what this command does is it takes the current line and it runs that line in the console. So I've assigned the keyboard shortcut Control-G. And so what we see is Control-G runs that notebook line in the console. And I can just keep basically stepping through my notebook. And you notice even when I'm on a cell, if I Control-G, it just runs that single line. And so it's a way to sort of break up, even in a big cell, you can break up individual commands inside of a cell. And in fact, it's even smarter than that. Here, let me, for I in range 10, print I. If I press Control-G here, it's going to recognize that, oh, that's not a complete statement. So it's going to try to find the complete statement that I'm inside of and run it and then step through it. So it tries to be a little bit smart about letting you sort of step through sequences of code that are smaller than a cell while you're experimenting in your console here. Just like you can drag cells from a notebook to a console, of course you can drag cells from a console to a notebook if you were experimenting and you want to save some of the results of your experimentation. And of course everything works with files as well. So let's open up a new file. Let's put it off to the side. Let's close that. And let's make a new file, and I'll rename it to a Python file, but it doesn't have to be a Python file. It could be any file. I can drag a cell from a notebook into a file. I could drag a cell from a console into a file. I can even select some code, and if I remember right, drag it into a cell here to copy it and paste it. So we try to make the tools work together really well, and where drag and drop makes sense, that you can move things from one tool to another. Talking about files over here, let's see, did we demo that you can hook a console up to a file? Yeah, you demoed this. So I'm going to go ahead and close this console and create a new console for this editor. I have to choose a kernel because the file doesn't have a specific kernel associated with it. So here's a Python 3 kernel. And as Stephanie showed, you can highlight it and press Shift-Enter to run that code. But the cool part is you get more than that. Now this file is associated with the kernel. So import matplot, and I can press Tab, and I get tab completion now in my code editor. So this code editor is associated with the kernel, so you get the same tab completion that you get in a notebook now in this code editor because it can talk to that kernel. I'll show you one other thing about consoles associated with notebooks in particular. Let's open up this console. Okay, so I'm going to run this cell in the notebook, and you notice that it doesn't appear in the console. Like the code is run in the kernel, and the console doesn't show that the code is run in that kernel. This is handy if you, for example, we have the variable I here. I can inspect sort of the kernel that the console is talking to, and I can print out a data frame that is in my kernel, etc., and keep it off to the side and sort of play in my notebook, and then play in the Scratch console area and sort of have two different ways of talking to my kernel. One way that's going to be the way that I keep in my document, that's sort of my persistent workflow, and then one way where I'm just debugging and like asking what variables are, or keeping a big table off to the side that I can reference later. Sometimes it's handy though in a console to be able to have a complete record of all the code that I ever evaluated. And if you right click on the console and show, let's see, here we are, show all kernel activity. What this does is it says, okay, console, anytime anybody evaluates code in this kernel, I want you to log it to this console. So now what happens if I run this cell in a notebook, you'll see that it appears like I ran it in the console, or at least it's logged in the console. And this is handy if you're in a notebook, and remember, sometimes you're jumping back and forth between 5 different cells, and then you run a cell up there, and then you run a cell at the bottom, and you kind of lose track of what you actually evaluated in the order that you evaluated. And so this is handy to keep it sort of an immutable log of all the computations that you ran. Even if you change a cell and rerun it, and you forgot, oh wait, what was it before? This is a handy way to keep off to the side of exactly what code was run in the kernel and in the order that it was run. All right. Let's see. Code completion. We did that. We did that. We did that. And then the last thing I'll show is Jupyter widgets are fully supported in JupyterLab. How many people have used IPyWidgets? Okay, and some people I think were in our tutorial earlier. IPyWidgets are a fairly popular way of getting interactive input from a user. As an example, here's a slider that's in your output, etc. There's a couple of cool things that you can do with JupyterLab and widgets. One, there's a special widget called the sidecar widget that's JupyterLab specific, and what it does is it takes whatever you're displaying and throws it into a sidebar. So in this case, for example, we're creating a sidecar and using it as a context handler right here, and we're displaying this int slider. And so if I run this code, what it does is it pops up on the right sidebar the thing I was trying to display. So this is handy if you're trying to programmatically do a bunch of stuff and you just want to throw some stuff over on the right-hand side to keep it as a reference as you keep going through your notebook. You kind of have some of this effect if you wanted to take this widget right here and pull it out of the notebook. You could right-click on it and create a new view for the output. And that what it does is it copies this output into a new tab. And it's a complete copy, live copy. You can see as I drag things around in the copy, the original output is changing and vice versa. It's a completely live copy of this output, but it's nice to be able to take any output. If it was a table or whatever, you can right click, create a new view for that output, and now you have your table off to the side in a tab. You can keep working through your notebook and sort of keep that as a reference in a tab off to the side. This becomes a lot handier when you're dealing with interactive widgets where you are modifying the widget as you go through the notebook. So here's an example of an interactive widget that's a map. So I can zoom, I can pan, etc., and I can change things about this map programmatically. I can add controls to it, I can start drawing on it, but as I evaluate these cells down here, you'll notice that the map's gone. Now I have to keep scrolling up and down to the map that I'm actually modifying in my code. And so this is a great opportunity to do this create new view for the output. You can drag it off to the side, and now this output is sitting over here, and as I go through this notebook, I've added this draw control. I can draw a region on the map to sort of specify, okay, this is the region of interest, and now I can query that region. Here's the polygon from that last drawing. I can clear the region. Let's see, this is a polygon, so there it clears, etc. And so I'm working with this output that was up here, but it's off to the side where it's a very convenient place to work with it or to look at it as I'm continuing to execute code through this notebook. And that's one of the nice things about using IPyWidgets and this interactive widget system with JupyterLab. And then one last thing with the widgets in JupyterLab, there's one setting, save widget state automatically. If you use IPyWidgets, sometimes you want to save the state of the widgets in the notebook to either publish the notebook online, or to be able to have anybody, when they open the notebook, to have all the widgets come up with exactly the map how you had it when you save the notebook. And what it is it's just a checkbox. It's a setting that's either on or off. If it's on, it means anytime you save the notebook, then the widget state is saved to it, which bloats the size of your notebook, but gives you a lot of interesting information. Like when you open the notebook, all the widgets come up. And when it's off, the widget state isn't saved to the notebook. So I'm happy to talk more about those with anybody that would like to. But those are some of my favorite features in JupyterLab that we haven't mentioned yet. Okay, questions before we move on? Yes?
I see there's an extension for code linting. Will that be a default Jupyter?
Oh, good question. So the question was, there's an extension for code linting. Will that be a default in JupyterLab? I don't know about this extension. That's great. I love it when there's extensions that you don't know about. That's sort of the genius of JupyterLab, is that, and open source in general, is that it enables you to modify your tools to your liking. I haven't seen that extension. It would be awesome if we had a code linting extension. In general, the philosophy of JupyterLab is to make it very easy to make extensions, and we're making it easier and easier as time goes on, and to have a robust third-party extension ecosystem. In fact, we might mention here, if you go into the settings, you can enable the extension manager. So if I turn it off and then turn it back on, you'll see there's a big scary warning. And the reason for the scary warning is we're not vetting the third-party extensions. This is random code from random people on the internet. So use it at your own risk. But if you go ahead and accept that risk, then you can enable the extension manager. And instead of using the command line like we did in the README, there's this nice little extension manager extension that comes with JupyterLab. You just have to enable it and agree to that warning. And what this does is it goes through NPM, which is the JavaScript package manager, and says, we have a convention that any JupyterLab extension has a specific keyword associated with it. So we just search for everything that has that keyword associated with it. And here's your extensions that you have installed. And you can search. You said linting. So let's see. Here's the search results. That's not it. There's all sorts of extensions, and you can install and enable them right here. I'm not sure what extension you were talking about, but point is that there's beginning to be a very robust and large third-party extension ecosystem, and I'm sure it will only continue to grow.
The third-party extensions in their settings be configured in the settings menu.
This is a wonderful segue into our Let's Write an Extension part of our tutorial. So, in order to do this, I want to show you something about JupyterLab. So let me open up a new page. If I can type into Google. That's on. So I'm going to open up the JupyterLab source code. If I can pull it up. All right. So here's JupyterLab. And inside of JupyterLab, here is the way that JupyterLab is built. In fact, I'm going to show you two things. In the packages directory inside of the JupyterLab inside of the JupyterLab system, there's a huge number of directories, and you'll recognize some of these directories: CSV viewer, console, CodeMirror, which is our code editor, notebook, main menu. Each one of these is a plugin, an extension in JupyterLab, and it provides some functionality to JupyterLab. In fact, JupyterLab itself is a very, very, very minimal application shell, and about 70 extensions that come with JupyterLab is sort of the core set of extensions of JupyterLab. And we've designed the system so that these extensions have exactly the same priority and capabilities as any third-party extension. Or phrased another way, any third-party extension has exactly the same privileges and capabilities that the built-in extensions do. And so, yes, the answer to your question is yes. Anything that a built-in extension can do, a third-party extension can do. And we designed this very deliberately to make it very easy to customize JupyterLab. In fact, various people take extensions out of JupyterLab and replace them with their own, or take all the extensions from JupyterLab and add their own, and every extension sort of lives on equal footing on top of a very, very thin application shell framework. So everything in here, status bar, even the menus, the notebook reader, MathJax, the math renderer, the inspector, that was the contextual help, how to view HTML files, the file editor, the file browser, the extension manager, like everything is a separate extension. that can be customized, can be overridden, can be pulled out of JupyterLab, pulled out of a custom distribution of JupyterLab, etc. And you'll see right here, this is, let's see, I'll go back to this package JSON. This file here is actually how we build JupyterLab, and I mean, this is the list of extensions that are inside of JupyterLab, literally. So you can add your own extension just as easily and customize it using settings, add things to the menu bar, add commands to the palette, add keyboard shortcuts, do anything that a standard extension can do. All right, so let's make an extension. There's a couple of different ways to make extensions in JupyterLab. And we've chosen to demo one of the easier ways. Essentially, there's a general extension to JupyterLab that's not too hard or convoluted to make. It's a pretty straightforward process to make a general extension to JupyterLab once you get past NPM and JavaScript and things like that. But we've made that boilerplate easy to get to. And then we've taken two particular kinds of extensions and made them really easy to make. Theming extensions, like was mentioned before, is very easy to make just a custom theme. You just basically write your CSS and plug it in, and we'll recognize it as a theme extension. And then the other kind of extension is the kind of extension that recognizes a file type and displays it. So for example, the Markdown file type, this Markdown preview, something like this, that will look at a file and it will render a tab with whatever that file stuff is, whatever that file contents is. And those extensions we call rendermime extensions, and that's the kind of extension we'll make today. So if you go into exercise 4 and open up the exercise 4.md, and in fact, let me open it up in a preview and make it a little bigger so we can see it better. All right, so what we're going to do is we're going to make a special kind of extension that recognizes a special file format that we'll make up called certificate, .cert.json. And essentially, it'll take this file, it'll read the data in it, and construct a nice certificate. So the first thing to do is we've made it very easy to get started with extensions, and we use Cookie Cutter. This is basically a templating engine. It uses the Jinja 2 templating engine, and it takes this template and creates an extension for you. So I'm going to go ahead and open a terminal. And let's see. I'm going to go ahead and go into... Let's see, that's my root directory here, so exercise 4. All right, so now my terminal is in the directory that you're seeing in the file browser. And let's hide the side and pull the terminal over to the side so we see our instructions as well as the terminal. And I'm going to run this one piece of code, cookie cutter space, and then this URL. And I invite you to follow along with me. I'll get you started, and then we'll have you work through the rest of it. So I'm going to paste the command in. Cookie Cutter is one of the packages, one of the Python packages that we had you install. And let's just press enter. Okay. It says you've downloaded it before. Do you want to re-download it? Yep. All right. So what it's going to do is it's going to ask you a few prompts to get started with this template. So your name. So Jason, your email. Jason@example.com, which is obviously a fake email address here. The extension name, I'm just going to go ahead and copy it straight from these instructions. My certificate viewer. Let's make it a little smaller so that I can see it better. Viewer name. So this is going to be when I right-click on a file, open with, the viewer name is the thing that appears in the right-click menu here. So when I right-click on a certificate file, like this .cert file right here, I want to see open with certificate viewer. So that's why I put certificate viewer here, it's the viewer name. And then MIME type. So this gets this is where it gets a little bit convoluted. So every sort of format, you can give it a key, and there's this database of format key versus the actual format definition. We're actually going to make up our own name for our own format and use the pattern that's used in the standards, and that is application/VND, which stands for vendor, dot, and then some organization that you control. I'll just use example in this case, dot, and then the name of the file format that you're dealing with here. So application/vnd.example.certificate is well used for the name of my file format. Typical is like image/png or text/plain or something like this. So I'm just making up a name for my file format here. And then MIME type name, this is more of a human readable name here. So I'll just call it a certificate. The file extension type. So here's my example file. I'll even open it up so you can see it. This is the file format that I have in mind. It's just a JSON file. It has two fields, a given and an event field. So let's see. I want to call it, these files will be .cert files. So make sure to include the .cert. And then finally it asks me, do you expect this file format to be a string format? Just a plain text string, or do you expect it to be JSON? If you expect it to be JSON, then we do some extra decoding of it for you and give you a dictionary rather than you having to parse the JSON yourself. And so in this case, my file format is JSON, so I'm going to answer 2 for JSON. All right, so what it did is, if we refresh this file browser, it created a new directory, my-certificate-viewer. And in this directory are a few files, and we'll walk through these files, and then I'll have you work through the rest of the instructions of the tutorial, of the exercise. All right, so let's look at these files. Let's see. I'll leave the terminal open, but maybe in the background here. Okay, so inside of my directory, inside of this directory that was just created for me, I have a number of files. Let's look at these in turn. So I have README. Just the standard README for my new extension. A tsconfig JSON. Let's come back to that one. Let's come back to that one. Let's go straight to the meat of the files, and that's this one right here. This is the actual source of my extension. First, I'm just going to import a few things. These are importing from packages, from JavaScript packages. So everything in JupyterLab itself is a front-end thing. It's a browser thing, and so it's written in JavaScript. And so we use the JavaScript package manager, which is called npm. And we use JavaScript conventions for these sorts of things. And in particular, these package names, you can think about it as the @ signifies an organization. So this is the JupyterLab organization / and then the package name. So it's the RenderMime interfaces package module inside of the JupyterLab organization here. So I import a few things, and there's some boilerplate, set up a constant that I'll use later. And the meat of the matter actually is down here at the bottom. And then, so let's look at the bottom, and then we'll come up and look at the middle. So at the bottom, I basically have some of the stuff that was in the template. I'm creating an extension, and in fact, in the very last line, I'm exporting that extension. That's what JupyterLab's going to look for out of this file. It's going to look for an exported data structure and this data structure defines my extension. I need to give it a unique name. So here's my unique name to identify this extension to JupyterLab. We'll come back to this renderer factory. That's what's defined just above here. This says, it's going to be used in preference. There's a ranking for these RenderMime extensions for the file format. Here's some of the things that you saw from the template. The data type of my file format is JSON. Here's the file type that my extension is defining. I'm going to call the files certificate files. Here's the MIME type. Here's the extension. So this is telling JupyterLab that it now can recognize .cert files. They're certificate files, and I know how to handle them. And here's my actual extension. I say, well, my extension's name is certificate viewer. It's going to be the primary reader for certificate files, which are these file types that I've defined right here. And here's the file types, and it's going to be the default for that particular file type. So when I double click on certificate files, i.e. things with a .cert, it's going to pull up my viewer. And then, let's see, up here, I passed it in the extension metadata, in the extension data structure here. I had to pass it a function that's going to create a new widget, a new tab panel. And that's what this is right here, this renderer factory. It's saying, one, it's safe, i.e. it won't sort of do bad things with arbitrary code, etc. Here's the MIME types this handles, and this function here is saying, you give me some options, and I'm going to give you back a widget that you're going to put in this tab. And that widget is up here. So this is an output widget, and again, there's some boilerplate here that you don't necessarily need to follow at this point, but you can sort of understand, or we'll look at the different parts of the code here. So it's an output widget. It's extending a class that comes with JupyterLab, and essentially what it's going to do is it's going to be constructed, and then there's a function that actually takes the data and renders that data. And so here in our construction, we just save the variable that comes into us, the MIME type that we get from the system. And here we're just going to take the data, pull the MIME type that we want out of this data, and then we're just going to stringify. Remember, it's JSON data, so we're going to convert it to a string and set it to the DOM text content. And so the end result of this is just going to be printing out the file for now. Let's go back up and look at the rest of the files that we skipped here. The package.json file, this is JavaScript package manager metadata. And let's see, I guess we have the JSON viewer here. So the name of my extension is my certificate viewer. Here's the version. Here's a description. Here's that authoring information that I mentioned. These 3 lines are important. This line is going to tell JupyterLab where to look for the extension. We'll skip this line for right now. This line tells JupyterLab where to look for the styling information. And then a couple of conventions. Keywords, this keyword identifies this as a JupyterLab extension when JupyterLab is searching in the repository. The files is just telling it, when you package up this extension, include these files that are in the extension. This key is an important key. This is the key that tells JupyterLab that this is a JupyterLab extension. And in fact, it's not just a JupyterLab extension, but it's this render MIME extension type, this simplified extension type. And then the rest of this is just some boilerplate code that basically defines the dependencies, that the other JavaScript packages I depend on, and some building commands. And the tsconfig, we're actually writing this in TypeScript, not JavaScript. TypeScript is a language that compiles to JavaScript, but provides basically typing on top of JavaScript. So it makes things a little bit nicer, a little more correct, catches your typing errors, as in your types errors, before they hit JavaScript. And so this is just a configuration file for TypeScript. All right, so let's actually install this. I go back to my terminal, and there's my file, my directory for my extension. And I'm just going to Jupyter, let's see, I guess first go into my certificate viewer. And the first thing I'm going to do is pull down all my dependencies. So this is, let me first activate my environment that has Node.js. This is the environment that we set up for this tutorial. So Node.js is installed in here and things like that. And I'm just going to go ahead and JLPM install. JLPM is the package manager that JupyterLab uses. Essentially, it's Yarn. If that doesn't mean anything to you, that's fine. Just You can use the same package manager JupyterLab uses by doing JLPM install. What this is going to do is it's going to download from the internet all the dependencies, all the JavaScript dependencies that my package depends on, and it's going to compile my package. You'll notice a few directories that show up here. Node modules contains all of my dependencies and their dependencies in the entire dependency tree. If I double click on it, you see there's dependencies and dependencies of those, etc. And the source file wasn't a JavaScript file. It has this extra typing information, like implements this thing, the options is this type, etc. And so what TypeScript does is it takes this TypeScript file that has extra typing information and it compiles it down to JavaScript and it puts the JavaScript file in the lib folder. And so this is the actual JavaScript file that's generated from my extension. And this is the JavaScript that your browser is going to run. So these are details to help you understand sort of what these files are about. Most of them you can ignore while you're just getting started here. And you just run this JLPM install. It pulls down your dependencies and builds your extension. And then the next thing is to install your extension. So JupyterLab extension install. And then I'm going to just give it the name of this directory here. So I guess I'm inside the directory, my certificate viewer, so I'm just going to go ahead and do dot. So JupyterLab extension install dot. And so what JupyterLab is going to do is it's going to take all of those dependencies that we already saw at JupyterLab had, those 70 packages or so, and it's going to add this directory, and then it's going to rebuild all of that JavaScript and compile all the dependencies of everything, deduplicate everybody's dependencies into one big, huge, well, actually about 5 or 6 big, huge JavaScript bundles. And those are the JavaScript bundles that are going to be sent to my browser. And it's doing it right here, building JupyterLab assets. Okay, so JupyterLab is rebuilt now with my extension installed. And I can see that by doing JupyterLab extension list. And I see I have a few extensions that I've installed already, like the widgets, the GeoJSON, etc. And I see I have my new local extension right here, and here's my directory. So I've just installed the extension that I just built. And in order to actually see it in JupyterLab, I'm going to have to refresh so that my browser gets a new copy of the JavaScript. So I refresh. The workspaces should keep everything the way it was. And now I see that if I go back up to my exercise 4, if I right click and open with, I now have a certificate viewer. This is my extension. And if I click on it, remember all it did was it took the JSON data, stringified it, and put it in the text content of the DOM node. And so basically it was just printing it out. Okay, so that's where we are to now. Why don't we let you work up to this point, and then if you want to keep working ahead, the instructions. So here's the installation. You can check what extensions are installed, etc. You can verify that it's working by right-clicking on it and having it in the open with, or you can just even double-click on it. And then once you get to that point, go ahead and keep going. You can open the file and customize the display by copying this code in, and customize the styling by copying this code into the CSS file. So go ahead and open up the exercise 4 and work up to this point and keep working. All right, I'll just work through the example here, and then so basically I'm copying this text into this to replace this line. Save, and then I'll go to the next step as well, which is copying this CSS into the style index.css file. I'm saving both of those, and I just run JupyterLab build. And that'll automatically pull in the directory that I installed. It'll pull in the changes and rebuild them and rebuild JupyterLab. And it usually takes an excruciatingly long time. And then there it is. You can do JupyterLab Watch instead. I'd already launched JupyterLab but you can do JupyterLab watch, and it'll just watch for changes and rebuild. But even that rebuilding is going to still redo this Webpack step. So, okay, so it's rebuilt, and now I refresh. And now, with any luck, I can double click on my .cert file, and there's the viewer. So the nice thing about this RenderMime viewer is that we've now taught JupyterLab how to handle this particular MIME type. And we've said .cert files are this particular MIME type, but there's other places where this MIME type comes up. And so, for example, in this notebook, if I change the code here, I have a certificate object, a certificate class that I can create instances of. And the certificate class tells IPython that, hey, to display me, you can give a rich display of me, and in particular, here's the data corresponding to this particular MIME type. And JupyterLab understands this MIME type, so we end up getting a nice visual representation of this particular class that's based on our viewer. So our viewer acts both as a file viewer and as a notebook rich display viewer because it's tied to a particular MIME type that we speak a common language here. Oh, sure. Yes, the viewer does live updates. So if I right-click on this and open with the editor, let's see, SciPy 2019, and my name is Jason. And so basically, both viewers here, the editor and my viewer, are talking to the same common model. And as that model is being updated by the editor, my viewer is getting a notification that, hey, the model has changed, re-render yourself. And so you end up with live updates, just like the Markdown preview. So that's a simple extension. Congratulations, you've written your first JupyterLab extension. Where to go from here? You can obviously make more file format viewers like this. One other place I would say is the next sort of step up for extensions is either move to a theming extension if you want to change the theme, or to go to, we have a new tutorial that is, I'll do it in JupyterLab here. Go back to JupyterLab. If you go to the help JupyterLab reference, and let's go ahead and close all the tabs to the right here and close that down. So here's the JupyterLab reference, and inside the JupyterLab reference, we have a bunch of documentation on writing extensions, and in particular, here's at the very end of the developer guide, there's documentation on writing a very simple extension, which is a little more complicated than a file format viewer. It actually takes the NASA astronomy picture of the day and puts it in a panel. And so it picks a random astronomy picture of the day and puts it in your panel. And so here's a tutorial that's sort of like the exercise we just did, and it just walks you through, here's the cookie cutter, use the cookie cutter to generate sort of the boilerplate, change this, change that, and walks you through getting an extension that looks like this, and it adds a command to the command palette. And when you run that command, it opens up a tab. The tab, refreshes. When you refresh the tab, it stays there, etc. So each part of that functionality is another chunk of code, and the tutorial walks you through that. So I would say that would be the next step if you wanted to explore more writing extensions in JupyterLab. So again, I think the genius in open source is you have the tools and the capability to modify the tools to actually fit your workflows. And that's what I'm really excited about JupyterLab. We've written a lot of extensions, all these 70 some odd core reference extensions that we think are really valuable and core to workflows. But what I'm really most excited about is the extensions that you guys are going to write that are stuff that we hadn't even dreamed of that makes your life better. And so, yeah, with that, there's JupyterLab. So let's have a Q&A for the last 15 minutes or so for any questions that people want to ask. Do we have an extra mic as well, or is this the only mic we have? This is the only mic we have. Okay.
Just one thing on extension and files. Right now, as you can see, when you open a file with an extension, all the data from your file is sent to your browser. So obviously, you won't send a file which is several gigabytes or several terabytes. And we are working, it's not ready yet. We're thinking about how to do that, on how to expose remote datasets to JupyterLab. So if, for example, you have terabytes of HDF5, how to have an extension that you have an HDF5 that appear on the file browser, and you double click on it, and the extension would only will be able to stream data from the HDF5. So just show a summary, and then you click down, and you get only a subset. So those are things we are working on. And also, like if you don't have a dataset which is on a file but on a bucket in S3, how to mount this bucket into the JupyterLab file viewer. Both so that you can browse it, and also when you drag and drop it from within the file browser to a notebook, it would directly insert the right API calls so that your users can load the datasets. So you don't have to learn about everything. So there is a lot of also future in JupyterLab, and we invite you to come to the sprint to try to work on it and discuss with us what are the next steps.
And then I'll segue from that. Come to the sprint Saturday and Sunday if you'd like to work on JupyterLab. If you go to the JupyterLab GitHub repo, you can go to the issues, and in particular, go to the good first issues. So under the labels, you click on good first issues, and there's tons of, 31 open good first issues. And most of these good first issues, we've tried to specify, here's a random one, specify exactly where in the code you need to make the change for this good first issue. So open the code, here's what needs to be changed, etc. So there really are good first issues to be able to start JupyterLab development in the core, or come to the sprints and write your own extension. We'd be happy to help. Okay, questions for any of us or Darian or whoever else?
Excellent presentation. Really enjoyed it. In terms of scheduling notebooks to run, like through a task scheduler or something like that, is there an easy, efficient way to set that up? Do you want to repeat the question?
Yeah, so the question is, how do you schedule notebooks through like a task workflow type infrastructure? Yeah, that's a really good question. You want to talk about Papermill?
Yes.
Okay.
So yes, nothing about open source, that we have a lot of companies involved. You've seen Bloomberg here. Netflix is also quite involved. And if we go to... so Netflix has this github.com/interact. Not Gitter, GitHub. And not IM, Chrome. You see that it's late. And not HTTPS. So Interact is another view on how to display notebooks. They, for example, have an Electron app that you can run on your browser. And they've done a lot of work. And in particular, I would suggest for you to look at Papermill. That's what Netflix is using internally to schedule notebooks in jobs. And they have a lot of, opinionated decisions of like notebooks are read-only once they're published. It's on S3, it's templated, and it's on top of NB Convert. So that's one of the things, and they've published some nice technical blog posts about that. And the way they use that is to basically run analysis pipeline. And once you want to, if you think something was weird, you can drop back into the notebook after the fact and tweak the parameters and see what was happening. But they're running that on crons. And that's developed by the notebook team at Netflix. Really nice blog posts they have. If you Google for Papermill and Netflix blog, you should be able to find that. Yes, beyond interactive notebooks, there are a couple of those. That's what I would suggest, to not sign in. Don't know how to not sign in.
Escape.
Yeah. And I don't know. M is not here this year.
Not sure who's here.
I don't think she's coming. Matthew, but sometimes they are at SciPy. You can find them at various Python conference. And they're online. You can also ping them on Twitter.
So there might be a video of the PyCon talk.
Yeah. There is a PyCon talk. There is also a JupyterCon of last year talk with different things they've done.
Other questions?
Anything you would have loved us to do differently for next year?
So this is not that, but I'm wondering any thoughts on where you see JupyterLab going in the next 5 years?
Excellent question.
So where is JupyterLab going in the next 5 years? Well, definitively we want to make an OS and then our own hardware. No, just kidding.
So we still need to make an email reader for it, right? Well, let's see. The Jupyter Notebook lasted for about 5 years, right? So maybe JupyterLab is replaced in 5 years. I don't know. Hopefully it's on better foundations and it'll last for a lot longer. But
5 years to build it.
we better start working on the next thing right now. One major feature for JupyterLab that we really want to start working on now that 1.0 is out is real-time collaboration. And that's going to be a major lift, not only in the front end, but also in the back end and the architecture. It's sort of the Jupyter architecture, not just the front end architecture. So that's a major thing. I think we'll see an explosion of extensions. People are already, a lot of companies are already integrating JupyterLab in their products and incorporating their own custom extensions to interface with their services, etc.
Did we show the extension searcher in Jupyter?
Yeah.
That's one.
So the question was, where do we find the extensions? And well, Jason is showing here. On NPM, every NPM package which is published with a specific tag will be recognized as a JupyterLab extension that you can install. To extend that, if you want to really go to fancy stuff, I would love to see someone experiment with extension of JupyterLab written in WebAssembly, so that you can compile C to actually JupyterLab extension, so that you can do some actual computation in the browser. And we are going also to work with the Jupyter Hub folks to see how you can deploy that at scale. And the remote dataset we told you about is something which is interesting, also the publication side. But there is no one direction because it's a Lego set. It's basically like where do you see the Lego company going in 5 years? Well,
Everywhere,
yes.
Yeah.
Do many of the languages support the debug protocol yet?
Ooh, that's another good one. Yeah, the question was about the debug protocol. So another major thing that is being actively worked on right now is additions to the Jupyter protocol to support a debugger. And so in particular, the front end would need work to support a debugger, as well as protocol level things and the kernel supporting a debugger. So there's active work right now at the kernel layer and at the front end layer to both work together to support a debugger.
And again, it's not, we won't be the one doing all of that. Like the community can come and say, hey, we have those great ideas. Let's get together and let's suggest that to Jupyter. We have a number of workshops. Like in last month, we got the kernel workshops and dashboarding workshop, so widgets workshop. And some members of the community get together and say, this is what we want to get in Jupyter, and we can make that happen. So I would love, for example, to get more thing about completion.
So maybe we should ask you, where do you see JupyterLab going in 5 years, since you're part of the community? Where would you like to see it go in 5 years? Mm-hmm.
Our studio, I'm mostly working in R. So our studio, I think, has a lot of functionality that's really useful in debugger.
Okay, we'll count that as, one big vote for a debugger. Right alongside my huge vote for a debugger. I really want a debugger as well.
So one thing is that our studio can make assumptions that everything is in R. So that's why we are slower. I just want to show, let me just make quickly a new notebook. In IPython, you have the debug magic that allow you to debug post-mortem, or you can run some debugger, not as nice as we would like to. If I do def f called f of x called g of x minus 1, let's return that. And if I do g of
The other thing our student has is nice. You can run blocks of code and go through line by line.
return 1 over.
So for the record, yeah, running blocks of code and line by line. I agree. I think there's a lot of polish still as people use JupyterLab in their workflows that will make it, as we iterate on this and as we get user feedback and things like that, or as users are able to customize it more for their workflows, that we'll have a lot more polish on specific things that people need in their specific workflows.
So here I just critique a zero division error. In IPython, which is just IPython specific, you can just run debug as a post-mortem debugging. You can also do it while it's running, setting breakpoint. I'm just going to show post-mortem here. We just use raw input to get normal debugging, where now you can inspect the value of y. Oh, y 0. Let's go up. Now I'm in f. What was the value of x? X was 1. So you have some debugging facilities, but we need to get people from different language together in the same room to not kill each other, which is sometimes relatively hard, and say, let's agree on a debugging protocol. Let's agree whether the most recent stack is at the top or at the bottom, and stuff like that.
Stephanie, I want to give you the chance to answer that question about where JupyterLab is in the next 5 years as well.
I think just to tie it back to what we were saying in the beginning about Jupyter not being purely academic or on the business side, I really see it's built on a strong foundation of collaboration between different people. And so something I've really enjoyed seeing as JupyterLab has grown, and even at Bloomberg, as far as the number of developers working on it, I really see the community growing. And because it's built off of this series of extensions, I see more collaborations across companies. And for me as a developer, I think that's really exciting to have that openness, in terms of even someone at our company was working on Control F, and you get a lot of input from the wider community around what that should look like. And I think that really applies to almost all of the features that people want out of JupyterLab. I don't see it being one sort of private interest driving that. I think JupyterLab is really going to be this crowdsourced, and it's as someone who's been newer to JupyterLab too, it's a really open community. I think I'll do another plug for the Sprint Day. It's a really good community to start with, even if you're not as familiar with JupyterLab. So I think that's something that I hope and I kind of expect to see in the next 5 years, of just really bringing on board new people and different companies, and everyone sort of, it sounds kind of utopian, but working together on it. And I think that's why I've stuck with this work for as long as I have myself. Yeah.
So,
yeah, I guess if that's
I think
it.
with that, that's a JupyterLab tutorial, but we're happy to answer whatever questions people have. And so thank you very much. You've been great.